I'm Tom Rondeau. I'm a program manager with DARPA's Microsystems Technology Office. And before coming to DARPA, I used to run the GNU Radio project. And as a free and open source software project, we used to hold Hackfest to get our community active and together and to solve really interesting and hard problems that we were not able to do by ourselves. So I wanted to take that idea to DARPA and run Hackfests in a similar way to allow us to explore how DARPA can make use of the activity, energy, and capabilities of the open source community to solve some of our problems and to see how quickly and effectively we could leverage the technology being developed in the open could be for some of our big challenges. So that's why I'm running DARPA's Bay Area SDR Hackfest. So this one is focused on software-defined radios and unmanned aerial vehicles, or UAVs. So why we're running this Hackfest with software-defined radio and UAVs is to address some of the interesting questions that we have with using UAVs for DoD-related purposes. We've been behind a lot of the drone or UAV technology for many years now. And the commercial UAV industry has become really exciting and interesting. And so we've been running programs like, say, the Service Academy Swarm Challenge, which happened earlier this year, where we tried to grab the DoD Service Academy's students, bring them out to an area with a virtual battle space and have a red versus blue aerial swarm battle. Really exciting, really interesting technology that was being developed and training for our future warfighters. But they were focused on the application layer of swarming. And now swarming is a huge communications problem as well, where you've got a lot of radios operating independently and simultaneously in the same geographic area, in the same spectrum. So if you're just focused on that application layer of the communication stack, you suddenly run into spectrum congestion problems. So our solutions to managing that were simply based on what we could do with the application layer, as opposed to thinking through the entire that entire comm stack from the physical layer all the way up to the application layer. So being able to run about 50, I think they pushed it up to about 60 drones in a swarm at one time, was actually record-breaking to be able to do that, and they ran into the spectrum issue. And if you're doing that just at one layer, you're never going to solve that problem. So that's one of the reasons why we're running this kind of a Hackfest, is to explore what else we can do when we start using SDR. And so to me, when I look at software-defined radio, as from a developer or programming standpoint, SDR allows us to make the electromagnetic spectrum programmable. And so if we do that, we now have full control from the application layer all the way down to the physical layer. So when we do that, it allows us to program the entire system and make this spectrum, this resource that we have, part of our programmable surface. And now we're putting this software radio onto a drone, which now makes the drone a programmable extension of our entire system. So we've put together the system where we're taking a commercial software-defined radio, an Edis Research USERP B200 Mini, connecting it to a Raspberry Pi 3, and mounting this onto the drone. So now we have open access to everything from the physical layer of the RF through to the operating system, all the way up to the applications that we're trying to program. So the idea would be that if you look to what Intel has been doing with their drone light shows, which are not swarms, they're pre-programmed waypoints for hundreds of drones. What if we could actually make those hundreds of drones part of a real swarm and be able to manipulate real tactics with that level of and that expansion of a network of these systems? That's an exciting possibility and something that we're trying to develop for and run this Hackfest as a way to explore new solutions, new ideas, new innovation in this space. So to do this, we are pulling together an interesting structure to the Hackfest event. And if you've ever been to Hackfest, or maybe you've heard of them as hackathons before, this is combining some ideas from a lot of those different types of events. All right, so in the GNU Radio world, where I come from, we've been doing these Hackfests where we get the developer community together, sometimes the entire user community together, to address some of our biggest problems that we faced in the development of and the programming of GNU Radio and of software-defined radio. I want to carry that energy and that spirit into this, and that's what the hacker space represents. So this is just going to be an open environment. We'll need you to register as a general attendee, but once you're there, you get to come in for any or all of the 5 days that we are running this. Sit down with your colleagues, your peers, meet some of the experts in the area of drones and software-defined radio, discover new problems, help us address current problems that we know, build momentum into the communities as we're trying to address a lot of the issues that we face in both the software radio and the drone arena. So that's the hackerspace. And with the hackerspace, I wanted to make sure that we inject new concepts, new energy regularly throughout the week. Make sure people walk away with some really interesting thoughts and ideas for where to go next. And that's why the speaker series exists. I wanted to bring in some really big thinkers in the space of software radio, UAVs, and some of the cyber issues as well that we're adding to the mix here. And so Monday through Friday, every day, there's going to be 2 speakers. And you can see them listed on the slides here. Again, some big thinkers in general context. You have Cory Doctorow, Amy Stepanovich. Both look at the future of technology, the privacy concerns, the social issues that come about when you're designing and building out really incredible new concepts. And I think software radio, making, as I said, the electromagnetic spectrum programmable, UAVs now providing access to the airspace like we've never had before, those have great technical capabilities and also political, societal, cultural impacts as well. And so we're going to hear from them on that. But then we want to dive into some of the technology. And so Ben Hilburn, who now runs the GNU Radio project, will be speaking, followed by Heather Kirksey, who runs the Linux Foundation's Open Network Function Virtualization, and they're otherwise known as software-defined networking. So looking at the infrastructure of mobile systems from an open perspective. So SDR being a piece of that, SDN being another piece, how these come together and build really new and important open access to the information infrastructure that our economy and our culture relies on today. So then on Wednesday, we're going to be focusing on UAVs. So PK from NASA will speak on NASA's efforts from the aeronautical side of NASA on what drones are going to mean to them. Following that by Chris Anderson, who not only created and runs the company 3DR, which makes drones and drone software, is also running drone code for the Linux Foundation and working with the FAA to define the next generation of protocols and access and ways to manipulate these drones in the future. And so again, talking back to this programmable surface that I mentioned, so software-defined radio, and now putting software-defined radio, which is kind of this almost unconstrained tool for accessing the spectrum, we're now putting it onto a drone, which is this unconstrained tool for accessing three-dimensional space. Those surfaces now increase our security and cyber vulnerabilities. So let's talk to some of the hackers. And so we have Joe Grand and Sammy Kamkart to give a perspective on the cyber issues that we're creating, while also maintaining this excitement about how we can make stuff in this with these two technologies together. Then I want to finish off that week thinking about the real impact of policy and regulations of both of these, because again, software radio in the U.S. we have the FCC as a regulatory body, and we have the FAA as a regulatory body for aviation and drones. putting these together now causes an even bigger problem. So Linda Doyle, who runs Ireland's telecommunications research infrastructure, and Pierre DeVry, who works with policy and law from the University of Colorado in Boulder, will both give some really interesting insights into what this technology means, the possibilities of what we can do with it in the future, and also how we engage appropriately with our policy and regulators to make sure that we can do what we want to do. So that's going to be a really exciting way to convey a lot of new ideas and a lot of new information throughout the week. And I hope that energizes people to go home, continue to think about what this meant for them to be there this week, hearing these ideas, working on them simultaneously, and then taking that into the future. So finally, we've got really what's central to what DARPA is trying to get out of this Hackfest, which is innovation and technology and access to talent that maybe we weren't engaging with appropriately or as much as we could have in the past. So I put together these missions. And so the missions were team-based. Teams have applied to them, and we've selected 8 teams to come out with us in November for the Hackfest to work on specific mission problems that I've created. These are going to challenge them to quickly take the software, the open source software, the hardware that we've built for them, and see what they can do with about 4.5 days of continuous work to address the problems that I've invented for this, and those problems have actual meaning and an impact on the DoD's future use of drone and SDR technology. So if they can be successful with this, we are looking at that as a way to take new ideas, take this new innovation, and move it into the DoD. So for the missions, we have put together a set of hardware and we've built software for the teams to actually be able to use when they come out and join us at the Hackfest. They will not know what the missions are until they show up and get the problem book on Monday morning. And so we're really looking at a few things with how I've structured the missions. First, the idea is that we've put a lot of energy and people power and hours into writing software, this open source software, Linux, GNU Radio, all the other tools, the mathematics, the frameworks, the GUIs, all those other tools have been built upon the people for decades who have been focused on this. If you know those tools, is what I'm thinking, that within a short amount of time, this week-long Hackfest, you can actually make a difference. You can actually build technology that maybe isn't production ready, but actually proves a point very quickly and shows us innovative ideas to take and then build into more of a production level setting. But that it doesn't always take a multi-year long program to solve some of the problems because we have the technology that's been built. Secondly, I really wanted to engage an entire new class of folks that, as I said, don't traditionally work with DARPA. We call them non-traditional performers for a reason. So I've been engaging the hacker community, the maker community, and bringing some of them in as a way to explore this space as well. And so we're hoping to show or to see that different backgrounds provide us with different solutions and new ways of thinking about problems where we may be stuck in some of our classic and older ways of thinking about how to solve the same problems. All right. So to do this, as I said, we've put together some hardware. So this is the basic hardware setup that you're going to find for all the teams that come out here. We are providing every team with one of the UAV setups and one of the ground station setups that's shown on this slide here. These are all commercial parts, consumer-oriented parts. We're not doing any military technology here. We really are trying to make this both accessible and usable to the communities that are coming out here. So you've got, I mentioned before, the Edis USERP B200 Mini. This is a very small, it's a business card size software-defined radio that can go from 50 megahertz to 6 gigahertz. You've got the Raspberry Pi 3, which is, I believe the one we're getting is somewhere around $35. You can pick them up at almost any computer store these days. We chose these because of the local access to the Raspberry Pis through local stores near Mountain View or in Mountain View, California. Very popular tools for doing home development and hacking and building of new technology. The drone that we've chosen is the 3DR Solo. Now, the 3DR Solo is no longer being manufactured, but the tech team that I pulled together has a lot of experience with it. They are very inexpensive, and there is actually a huge supply still left for us to make use of. But what's also nice about it is that even though it's no longer being manufactured, the concept behind a small commercial drone like this scales fairly well to other similar tools. We just chose and settled on this one. But the idea is that we're going to now connect the USERP itself, the software-defined radio, as the physical communications layer to pass communications packets. These are the MAVLink protocol. Those are the protocol packets that tell the flight controller what to do. So this flight controller, the PixHawk 2, open, very accessible. It's kind of one of the industry standards for consumer flight controllers. So passing packets through the software radio physical layer into the flight controller, how does that make that drone behave differently, or what can we do to make it behave differently? So to get there, we're using the ground station that we've pulled together, which is just a standard laptop. It'll be a fairly capable laptop. But nothing nothing extraordinary. And then another Edis Research USERP B210, where we'll actually have multiple antennas if people want to try to make use of those. So giving this access to the hardware is one thing, but providing some basic software functionality I think is also helpful. So we created what I lovingly refer to as the stupidest thing that can possibly work. This is just a very basic path for users to create flight control packets through this MAVLink protocol, pass them through the ground station using GNU Radio to get to the USRP, to pass those packets to the USRP on the drone, decode them, and pass them into the PixHawk flight controller. That implementation, like I said, is very simple. It's not very robust. It's just proof of concept that this can work. I want to make sure that all the teams have access to at least this level of software technology to get them off the ground very quickly come Monday. Now, teams don't have to use this. This is just an example to prove that we can manipulate these drones over software-defined radio. But teams can feel free to use any other implementation they want. They can extend this as they want. They will have root access to both the drone operating system and the ground station operating system. So if they want to add their own software, they're perfectly free to do that. But I wanted to both prove the technology concept as well as prove our intent and intentions of running this Hackfest. So one of the things that we've done is, as I note here, this is free and open source software. We built our tools out of open source software. It is a GNU Radio module called GRUAS link. It is GPL'd, and we are providing it for free online using the Defense Digital Services GitHub account. So if you go to code.mil and follow through to their GitHub page, you can now get access to GRUAS link. And so we wanted to give the teams a couple of months to get used to this code, hopefully provide us feedback, bug fixes, new features that they think are usable and shareable for the entire community, and show that we are trying to actively participate in the open source community as we develop the technology that DARPA is still really interested in. So we can take this flow graph, you can make it your own. You can take this general MAVLink flow of packets and make it your own, and use this all to then solve the missions that I will be providing. So come November, the Hackfest takes place November 13th through the 17th at NASA Ames, which is at Moffett Field in Mountain View, California. The hackerspace will effectively open up lunchtime on Monday and then run throughout the entire week. The mission teams will be developing and operating in parallel with them at the NASA Ames Conference Center. We will encourage interaction between the teams and the hackerspace as people see fit. This is a very collaborative effort. This isn't really a competition effort at the end of the week. Teams are looking to prove to us that they have developed great solutions, not necessarily better solutions than anybody else. So collaboration is encouraged. If problems persist or ideas aren't working out throughout the week, I actually will, like I said, encourage people to engage with the hacker community that has come out to participate and to explore and to watch what happens. So there'll be things like the brainstorming sessions after lunch. These are ways for the hackerspace and the teams to explore and explain what they're doing, what they're interested in, what their problems are, if they have cool demos that they want to show people throughout the week. Come out there and give a few sentences on what's going on. So as the teams are doing this, as they're participating, as they're interacting with the hackerspace, their goal is leading up to the final mission judging on Friday. So come Friday afternoon, all the teams will have a 30-minute window to prove and to show off what they've done that week. So we'll go out to the range, which will be nearby. It's known as Building 45 at NASA Ames. That is our UAV range. Come out, give us a little bit of an insight into what you did that week, then fly the solutions that you've developed and show us what you've been able to do in this short period of time with the technology and the tools that are available to you. The judging will consist of myself and 4 other DARPA program managers from different offices throughout DARPA. And our intention is to provide informal feedback and then to understand what the excitement is, what the technology that was shown, where we think we can take it within DARPA and within the larger DoD, and then work later with the teams who showed us something really interesting to see what we can do about potential contracting and injection of their technology into our military programs later. So again, you're not going to walk away with the first, second, or third place. There's no participation trophy. This is really, did you make cool technology that the military could want and could use? And then we will close off the Hackfest with dinner and a few closing remarks. So I hope to see people come out here. I'm encouraging folks to join us for the general Hackfest, the hackerspace. Participate as you want, as you can. Come out and see this incredible lineup of speakers that we have. Watch what the teams are trying to do. Watch how this concept of innovation generation can make interesting things happen in a fairly short period of time. Thank you.